oxidation number is the number or is the charge present on a particular atom which it is having, or when it is combined with other element. So oxidation number is defined as the charge which atom appears to have or when it combines with other element. When I will discuss the rules for the same now, then it will be more clear to you. So oxidation number is the number or is the imaginary charge present on a particular atom it is having, or when it is combined with other element. It is very important concept, because otherwise you cannot do chapter 3 electrochemistry of class 12 also. Fine? So there are certain rules for calculation of oxidation number. Rules for calculation of oxidation number. First is the oxidation number of all the elements of different elements in their native state is always 0. Native state means the state in which they exist in nature. For example, I am taking hydrogen. Hydrogen occurs in nature in the form of H2. So oxidation number for hydrogen gas is 0. First rule is the oxidation number of the atoms of different elements in their respective native state is 0. For example, chlorine occur, for example, your oxygen occur in nature in the form of O2. So oxidation number here will be 0. Okay? Second rule. The oxidation number of a monoatomic ion is same as that of charge on it. Monoatomic means single atom. Suppose I am taking sodium. It is single atom. Its charge is +1. So its oxidation number is also +1. Similarly, Mg+2. Its charge is +2. So oxidation number is also. Similarly, fluoride ion, its charge is -1 and oxidation number is also -1. Fine? Because they are monovalent. Next is regarding the hydrogen. Hydrogen can combine with metals as well as with non-metals. So hydrogen can have plus and minus charge. When it is reacting with non-metals, then it will acquire plus charge. When it is associated with metals, then it will acquire minus charge. Like in NaH2, sodium is metal, it is having minus charge. Because sodium cannot take electrons. Okay? Sodium cannot take electrons. It only gives electrons. I hope is it clear? Second important, very important, regarding the oxygen. The charge on oxygen is always, oxide ion is -2. If it is this oxygen molecule, then it must be 0. But when it is present in the oxide form, its charge is, its oxidation number is -2. But there are lot of exceptions, like in peroxide, H2O2. Remember this. In peroxide, the charge on oxygen is minus 2. Oxidation. Okay, it is minus 1. In case of superoxides, it will be minus half, like KaO2. In this, oxidation number of oxygen is minus half. These are the exceptions. Okay? In peroxide it is different, superoxide it is different. Generally on oxide it is minus. Next is, if the compounds formed by union of metal with non-metal, suppose I am taking the example of MgCl2. So metal will always acquire plus oxidation state and non-metal will always acquire minus oxidation state. Okay? Because it is more electronegative, it has tendency to take the electrons. And because of its less ionization energy, it easily loses the electrons. Fine? Next, if element is formed by union of two different elements, so the element which is more electronegative always have negative oxidation state. Suppose NH3. Hydrogen can react with metal as well as with non-metal. So in this case, nitrogen is more electronegative than hydrogen. So it will acquire negative oxidation state and it will acquire positive oxidation state. Fine, I have already discussed the concept of hydrogen. Same is it. Next, in neutral compound, suppose it is CO2. It is neutral, overall carrying no charge. The sum of the oxidation state of all the members, all the elements is 0. Suppose I will take, what is the oxidation state of H2O? What you will say? 0. Because it is not having any charge. Okay? It is not carrying any charge. But if I will take the example of charged species, suppose carbonate, phosphate, then this total charge must be equal to minus 2. Suppose in this I have to calculate the oxidation state of carbon. I am assuming it X plus how many oxide? 3. Charge of every oxygen is minus 2. It must be equal to minus 2. Because it is not the neutral compound. So in cases of charged species, the sum of the oxidation number is equal to the charge on that species. Fine? These are the general rules of oxidation number. Now suppose I will say calculate the oxidation number of sulfur. Suppose I have to calculate the oxidation number of sulfur, assuming X, it is more electronegative, so it will acquire definitely negative charge, and hydrogen will acquire positive charge. How many hydrogen? 2. 2 into 1, so it comes out to be 0 because it is neutral. So answer will be minus. So what is the oxidation state of sulfur here? It will be minus. Fine. Likewise in CO2. Suppose if we want to calculate the oxidation number of carbon, assuming X plus 2 into minus 2, that will be equals to 0. X will be plus 4. Why minus 2? Because oxygen always carries minus 2. Fine? In the next class, we will discuss the average oxidation number bonds. Fine? These are the general rules for assigning oxidation number. Likewise, take one more. CH2Cl. Calculate oxidation number of carbon. It will be X plus 2 into 1 plus 2 into minus 1 is equals to neutral compound 0. So X will be, here X comes out to be 0. Okay? I hope this is clear to you all. Fine. In the next class, we will discuss more questions based on this. Okay? See you there.